It's hard to deny the importance of compressors in HVAC systems. They're driven by an electric motor, so that's where the money goes in. They account for the bulk of the work that is put into the system. The reason I want to emphasize compressors is because there are opportunities. And a big part of this course after the midterm, the second half of this course, is about industrial savings, so energy savings in industrial environments. And there are a lot of savings that can be had in the compressor world. So the most common type of compressor is the reciprocating compressor. So a reciprocating compressor basically looks like this, where there is a piston and there is an inlet. Sorry, that piston is going to start down below here. It's going to start down here. This is the piston, and some fluid comes in, and then the piston, it rises up within the cylinder, and then the fluid is now compressed here and exits, and the volume out is much less than the volume that came in. So that's your common reciprocating compressor found in a lot of HVAC systems, including small HVAC systems that are used residential and heat pump systems. Let's compare that to a rotary compressor. Rotary compressors are pretty cool. And in a rotary compressor, you have sort of a offset reciprocating sort of a shape inside that has veins on it, and these veins get compressed, like have a relative motion in and out, and this is like an offset cam situation, and the inlet is where the veins are making a lot of space. So there's an inlet here, and then the outlet would be where this offset cam is basically squeezing a small amount of volume. So the inlet had this huge volume, and then these same two veins, 1 and 2, are now going to move over to the outlet, so that will be one. It would be 1 and 2 once it's over here, but that same amount of volume, when it has moved over to this place, is now smaller, so it's bringing less volume out. And we can compare that to a screw compressor. Screw compressor, also very interesting. I'm going to take a cross section of it. And a screw compressor basically has these augers, and if I were to take a cross section of these matching augers, then the teeth of these matching augers need to come together. Very hard to draw, but if you're interested in this, you can look at some videos. So where teeth come together, there are pockets of volume, and they're being compressed. So here I can't draw you an inlet and outlet, because basically these are teeth that move together like basically like teeth of a screw matching together. So the inlet is in the page and the outlet is out of the page, and the fluid moves through the threads of these augers. So look to YouTube if you can't really get that from this diagram. And then a centrifugal compressor, this one's kind of interesting. This is also axial flow compressor. So a centrifugal compressor looks like a centrifuge, where it has some vanes, and the inlet is here at the center, and then the outlet is here. And so what happens is it's very high velocity in here. High velocity in here, and then the velocity is slowed down, so it has a very high velocity, and then there's very low velocity at the back, at the outside of this vane. So at the outlet, there's low velocity. And then our friend Bernoulli told us that, well, where there's high velocity, there's low pressure. And where there's low velocity, there's high pressure. And we can go through the Bernoulli equation, one side versus the other side, cross out, and we can see the relationship between pressure and velocity are inversely related. And that's how that one works. It's kind of neat. And then the scroll compressor is my favorite. There's basically a scroll like this, and then there's another scroll that sits inside it. One of them is stationary and the other one is not. And flow comes in, and then as the green one rotates, then that pocket of fluid is going to go, it's here, and then it gets compressed here and compressed in here. Basically, it travels through as one of these is rotating, and then the outlet is in the center along the axis. So that's kind of neat. So that's just a very quick summary, but all you need to know really about the types of compressors that are available in HVAC systems. And again, this is of great importance because there's a lot of energy savings available in compressors.